Welcome, Algebra 2 students, to your Chapter 4 project. We are going to put the whole thing together. We spent so long on Chapter 4 during a pandemic. It must seem so unrelated, but it's not. It is literally the fundamental of algebra. It is the basis for the rest of math. It all goes together, and hopefully with this project, you'll start to see how it's interconnected. Okay, you're going to be in groups. You're going to be given one equation from your teacher. So let's go over to the slides with me. All right. You're going to put your group members here. All group members' names, please. Okay, you're going to get an equation from your teacher. Do not type it in. I don't want to see carrots. Your teacher doesn't want to see carrots. You don't want to see carrots. Okay. You are going to either write it out on paper and add it in, or you can do what I did and type it in Desmos and then use your snipping tool or screenshot and just screenshot that part of the equation. And I'm just going to delete the words back. Actually, that doesn't matter because I think once I put it in here, nope, I guess I do have to delete the words. Boom. So I apologize for the dog barking. Ah. All right. Now, okay, let's try to get through this with the gardener outside, the dog. This is my 5th time trying to do this video. I've had an interruption every time. I just want to get through it. It's going to be a good project. I just need to get the instructions down. So back to the screen. We added, we're lucky with the microphone. You don't even hear it, but it's really annoying me. You should be watching the screen again. I added in the equation. I got it from Desmos. Speaking of Desmos, let's go there. Now listen, forget about these other equations. Here's the equation I chose for myself. Your teacher's giving you the equation. You're also going to take a picture of the graph, but Desmos doesn't give you the graph so that it's easy to read. I don't want this. What does this tell you about the equation? Do you know where it goes to positive infinity and negative infinity? Do you? Zoom out, go to an appropriate spot. But if you realize that you zoom out and it doesn't tell you much, this, not a good graph. So zoom in to where you can definitely see it doing what it does at the infinities, goes up to positive infinity over here, down to negative infinity over here, and go to your toolbar. Go to the tool, change your x values. I don't know what your x values are going to be. Every graph is going to be different, but there's a lot of blank space on either side of this graph. So let's just, I don't know, at this point, let's say -10 to 10. This is a great representation of the graph. This is a great picture to take because you can see the turning points. You can see where it definitely is going down to negative infinity, up to infinity. You can see the x-intercepts clearly. Take a snapshot of it. Go ahead. Add it right in here. Okay. Make sure it fits into the space provided. That's good. Cool. Ooh, now you got to answer this box. It's a polynomial with a what degree? Well, the degree of the polynomial is 5, so it's an odd degree. And it has a what type of leading coefficient? A positive leading coefficient. Great moment if you don't know what else to put or you don't know what graph you're looking at for your project to go back to 4-1, chapter 4, section 1, and find out what type of function you have. All right, now can you deal with the infinities? What's going on? Let's see. What is y doing? What is f of x doing? What is the red line doing as x goes towards positive infinity? Well, positive infinity is out here. What's the red line doing? It's going up towards positive infinity. What is the y doing as x goes towards negative infinity? Y is going down. The farther left I go, the farther down. So negative infinity. I added in 2 other things to drag around because your answers might be different. You might have 2 positive infinities or you might have 2 negative infinities. I don't know. Depends on what your group got. Now you need a label where the graph is increasing and decreasing. Here's what I want you to do. I want all the parts, by the way. Some of you did not do that before. But that's okay. We're learning. Insert a shape, an arrow. Then you got to click and expand. What is going on right here? Remember, we read from left to right. Go ahead, click in there, and we can say it's increasing. All right, now what's it doing from this turning point to that turning point? Well, insert, shape, arrows, I'm going to insert this type of arrow. So right now I can clearly see that my student knows that the graph is decreasing here and it's not done. You are not done. How many different arrows do you need? It depends on the equation you're given. We're going to insert one more arrow. What's going on over here? This accurately describes visually, where is my function increasing? Where is it decreasing? Where is it increasing again? Good. All right, let's go to the solutions. I already worked them out in my notebook, and then I took pictures of them to add on later, and we'll get to that. So I went to Desmos and I found solutions, right? I found -4, -1, and 2. So those are going to go right here. Okay. Let me go ahead and add a picture. Now, I want a picture where you clearly have these coordinates shown on Desmos. So I zoomed in actually previously because I got it all set up, and I'm going to insert that picture here so that I know you know where the real solutions, the real rational solutions are, and I'll size it appropriately to the graph. Okay. Notice that this graph doesn't need the stuff that I saw on the previous slide because I'm concerned about you identifying the real roots. Okay. Now I did a bunch of math that I'm going to show you in a second. So I did synthetic division. I did synthetic division. I found out there are no real irrational zeros. Those have rads. So none. And I found 2 imaginary zeros. They are plus or minus. So positive I can insert a special character. I can insert a rad. 2, and negative I. See, actually, if I can just copy and paste it. Yep, there we go. So positive I rad 2 and negative I rad 2. Now, how am I going to show, you had to do some work to get this, right? So here, I want to see a picture of all the work you did, most likely starting with some form of synthetic division. Okay, so that's what you're going to insert here. Oops, excuse me. There we go. So I took a picture. I'm going to upload it here. I should have labeled it better so I could find it faster. But here's all the work that I did to get me all the way down to, let's see, 1, 2, 3, 4, 5 roots. Checked it with the degree of the polynomial. And now the fun part. These are all our roots. Let's go backwards. Like, let's say we started at the beginning of 4, 6 or 4, 5. What does that mean? Show me it as a collection of factors. So you are going to, and you'll see it here. All you need to do is take all your solutions, all your roots, change all the signs and put them in parentheses, right? What are my solutions? -4, -1, +2, positive I rad 2, negative I rad 2. This is this polynomial as a collection of factors. Don't believe me? Go ahead, multiply it all out. I dare you. All right, this is new material for this section, this chapter. We've done it before. You're going to be assigned to translate your graph left or right by a certain amount. So I assigned myself what? I assigned myself to translate my graph left by 3. Remember that? Every time we just open up those parentheses around the x, and then if it's going to the negative numbers, we do a +3, and if it's going to the positive numbers, we do a -3. So your teacher is going to assign you left or right, and then a certain number. So all you need to do is take every single x and put it in parentheses with the appropriate direction. Check my work. That's it. Okay. You're going to do that. And then you're going to have the graph. make sure the graph, like check it. Does this look like 2 moved left 3? 2 minus 3 is -1. I am correct. And the whole thing looks like it's been moved to the left 3. Get rid of the original function. Go ahead, take your snipping tool. I want to see, and you probably can't see what's going on in the background. I'm taking a snipping tool. Here is I took a picture of my graph, and I'm going to upload it. Oh, by the way, since I should type in what my teacher told me, what I told myself to do, left by 3 units. And I want you to insert the graph, excuse me, insert image, upload from computer, called it translation left 3. And I also want to see the equation, which you just need to take straight from Desmos so I can see it. All right, I'm just going to get rid of the background words because I want it to look nice. All right, and then finally, do you remember how to reflect things over the x-axis, right? Over the x-axis, change all the signs in front of the x. Well, that's exactly what, here's our original. Take a look down here. Didn't I change all the signs? Didn't it rotate it around the x-axis? Yes, it did. Let's go ahead and get rid of that. Let's take a picture of this. Again, I don't think you can see what's going on in the back. Ooh, you know what? This isn't a good one to take a picture of. I wouldn't accept this as a teacher. Now it's better. You might have to re-center it. So I can see the turning points. I can see that it's going up to infinity over here and down to negative infinity over here, different than the original. Okay, so I'm going to take a picture of that to share with my teacher. Well, in this case, to share with you. And again, you might not be able to see what's going on my screen until, so I'm just copying it the way that you do it on a Windows PC. I'm going to insert the graph. Let's see, what's it called? Reflection picture. Excuse you, thank you. And I'm going to insert the equation. Okay, and that's it. You were given a polynomial. You figured out what the important part of the visual is. You showed where it's increasing, decreasing, increasing, or whatever's happening. You told me what type of polynomial, what type of leading coefficient. You told me about the infinities. You can leave the extras here. You found the solutions first from Desmos, and then you did some math to find any real irrationals, those are the ones with radicals, or imaginary. In my case, imaginary. You showed me the math here. You then took all of these, -4, 1, 2, IRAD2, negative IRAD2, and you changed all the signs, put an x in front of each one, put parentheses around each, and you showed this polynomial right here as a collection of factors. Then, in my case, I assigned myself to move it to the left by 3, so I went to Desmos, and I took all my x's, put parentheses around them, did the correct math, showed a graph. And I also reflected it. Everyone's going to reflect it over the x-axis by changing every single one of those signs and showing me a good graph that you might have to recenter. And that's our project. That is putting it all together. We did all this work to get this idea. And if you have a good idea of what just happened, congratulations. That means you learned it. All right. I look forward to seeing what you do.